In our last session, we have seen inheritance. So, there are various types. Instance variables. The methods using instance variables are called instance methods, and the methods using class variables are called class methods. So, if they are using the combination of both, then it at least if one of the variable is instance, then we call it as a instance method. Okay, instance method, instance variable, and class method, class variable. Okay, there is so this is all the class related code, student related code from our previous session. I have copy pasted here. Okay, let's see another method. There is something called static method. Static method means uh, there will be variables which are local to itself. It is not related to the class, it is related to only that particular method. Okay, it is related to only that particular method. Let's say for the student, what I can think of as local variables. Okay, let's say it is not related to student, just I'm defining some static method. Okay, the method name is static method. You can write any name as the method. Okay, here I'm having static method. So it should accept any parameters, A, B, C, A, whatever it is. Let's say A and B. So here I want to return A plus B. That's it. That's all. Okay. So if you're applying a static method, these variables A and B, these are not defined anywhere else. Okay. These are not there anywhere else. It is there only in the method A and B. So these A and B are accessible only inside this method. They are not accessible outside the method using the object reference. Let's see on this S1. You know how to apply all these methods, basic info, college, all this we already know. Let's see this static method, how to apply. Okay, let's see. It might throw error. Okay, it is giving error. So, sorry, we have to give positional arguments A and B. Here, let's say 10 and 20. Okay, see here what it is trying to take. Positional argument, sorry, it takes two positional arguments, but three were given. I have given only two, but why is it considering as three? So by default, whenever you are not defining the decorator, it will understand that first as the self one. Okay, the first method it is trying to take it as the self. So everywhere you are using the word self, it need not to be necessarily self, but that's the standard practice we follow in Python. So it can be A, B, C, X, Y, Z. The first is the placeholder for the self. Okay, so now on this method we have to apply at the rate static method, then only it will be able to understand that these variables are static variables and first one is not self. Let's run it. Okay, see here the static method 10 plus 20, it is 30. Okay, this is about the static method. So there are three types of methods and three types of variables, right? Let's write it down. Instance variables, and the method is instance method. So next is class variables called class method. And next is static variables called static method. Okay. So these are the variables and methods used in OOPS concepts. Okay. So now we know the methods and classes. Now we'll slowly discuss about the core concepts of OOPS. Okay. We have four core concepts in OOPS called inheritance, polymorphism, abstraction, and encapsulation. So these are the four main concepts in OOPS. Okay, let's see inheritance. Inheritance is like, in order to understand in simple terms, we have our parents, so we will inherit their property. So if we have the children, our property will be inherited by the children. So whatever property we have, maybe it might be land or house or gold or whatever is there for your parents, that will be inherited to you, and our property will be inherited by our children, right? Similarly, in these methods also, whatever are the properties here, what are the properties? They are the variables or the methods. So whatever variables or methods available in parent, that can be accessed through child. Okay. So let's see. 1 second. Okay. So let's define. I'll assume this as the parent class. Okay, the student as a parent class. Or let me define a simple function so that once you understand that, we'll slowly go into the other one. So, okay. Sorry, class of. I'll name it as parent. It is not mandatory to maintain it as a parent or whatever. So let's say I'll take it as a person. Okay, the class name is person. So I'll define an init method of self comma the person name. So here self dot name equal to name. Okay, let's say P1 equal to person of, provide a name here. Okay, so let's print P1 dot name. Print P1 dot name. Okay, so we know this. We have created a class. If we did not define any method, we have just used the init method, which is like a default constructor or to initialize the variables. Okay, so I have initiated a variable called name, and I have created a person object and I'm calling that name. Okay, it is printed. So now let's say I'll define a child class here. Class of that person might be student now. Okay, class of student. So this person has now become student. Okay, so whatever is the name here, I should take the name from this person class. Okay, the name should be taken from the person class. And whatever the methods available in the person, that should be accessible to the child class. Let's see. Def of init self comma. Here, let's say what are all the variables we can take. Self comma id comma name. Let's say these are the variables I need for this student class or probably college. Okay, so let's define here self dot id equal to id. So name you have to take it from the this method person class. So for that, what we have to do is we have to use a method called super. Okay, so super of super dot init. Whatever variables you want to take from the parent class, write it here. I just want to take the name. Okay, next self dot college equal to college. So now we have defined the variables. Now let's create a student at student object. Student of, here we have to pass all the attributes. Okay, so id is what? Let's say id is one, name, name and college, let's say. Okay, let us run this and see. So we did not print anything for s2. So let's see s dot id. Let's print it s dot name, s dot college. Let's see what variables we will get it here. Okay, we have got whatever we have passed here. Instead of that, let's say I will not pass name. Okay, it might say uh, one of the argument is missing. Okay, it might say one of the argument is missing. Let's try this. Okay, it says student missing one positional argument college, because this is treating as the name of the person, not as the parent variable. Okay, let's see how we can handle it. Sorry, here we will not create a parent object. Okay, let's say we will not create a parent object. Let's provide the name here. Okay, it is returning properly. Now let's say I want to have a uh, parent object as well. Let's see if this goes into the parent or not. And let's run it without the name. I think it will give error without the name. Okay, it's not taking. So ideally, the scenario is that whatever values we pass to this person, that will be inherited to the child. Okay, whatever values we pass to the parent, that will be inherited to the child. So here we have defined the name and passing it directly here. It is referenced from the parent class. We are passing value to the parent class, not to the child class. Okay. So, or else, uh, what we can do is, let's make the name as the first one. Then also it would have to, let's uncomment this and try to pass only two values now and see what happens. Okay, still here it's not able to understand. Anyways, we definitely have to pass three values. Let's comment it out. Okay, right. Let's see a few more examples. Let's add some methods here. Okay, let's add some methods. Def of person display. Okay, let's say this is a method to display the details of a person. Person info of self. Okay, let's write print. The person name is self dot name. So this is the name in details of the person. Here similarly, let's do a display method for student info. Here we have to write the word self. Okay, so here the student name is nothing but the person name. Print student name is, we have to refer self dot name, and print, let's say student ID also. Let's print it here. Student ID is self dot id comma student name is self dot name and studying in college self dot college. Okay, so let's apply these methods. S1 dot. So now what are the methods applicable on the student? So student can have student info and it will also have the details of person info. Let's say S1 dot student info comma S1 dot person info. Person info is not a method in the student class, it's a method in the parent class, but still we will be able to access. How? See here, let's say these are the details of the first print statement. Okay, student ID is one and student name is this and studying in college ANDH and the person name is Prabha. Though we did not create a P1 object and we are calling the person method here, it is able to call because it is inheriting the properties of the parent class to the child class. Okay, it is inheriting the properties. So this is called inheritance. Not only the methods, we can inherit variables, methods, whatever the parent has, we will be able to inherit. Okay, I'll copy the same example. So here, let's say I have another class called employee. Let's remove this. Now the person has become the student and student has become the employee. After a few years, let's say he completed his graduation and he has become an employee. So employee of, let's say I'll pass this student as the parent. See here it is like a parent, child and a grandchild. Okay, parent, child and grandchild. Now what are the properties this employee will inherit? Whatever are the properties of the student that will be inherited by the employee. Okay, let's see. I'll have an init method of self comma employee id comma name. Name should be the same. So college will also be the same. Name and college I'll be getting from here. And designation, let's say designation and organization. These are the additional details for an employee or maybe his salary. Okay, these are the additional details of an employee. The same person has now become an employee. So let's define his details. Self dot id equal to id, sorry, employee id and super. We have to use the super method to inherit the values from the parent class. Dot init of name comma college. Now self dot designation equal to designation and self dot org equal to org, self dot salary equal to salary. Okay, these are the details of an employee. Now let's see. I'll have a display employee or employee info. Employee information I want to display of self. I'll write everything in a single print statement. Print employee. Sorry, let's say employee is introducing himself. Uh, sorry, I am name. Self dot name is the name of the employee. Studied in self dot college. He is introducing himself. Let's say studied in some college. Joined as designation. Joined as self dot designation in self dot organization with a salary of with a salary of one second, let me adjust the screen, with the salary of self dot salary. Okay, we did not use employee ID and student ID anywhere. Okay, that's fine. Now, sorry, this has to be indented. Okay, so let's create an employee object. Sorry, this is class, my bad. This is class of employee. This is a method inside the class. Okay, right. Now this looks good. Let's create a employee object e equal to employee of, what are the details we have to pass here? Employee ID, let's say 100, name, college, designation, organization ABC, salary, let's say 50,000. Okay, so I'll apply. What are the methods applicable on this employee? First, let's see employee info. Okay, there is a mistake here, dot. Okay, another mistake, student init method, missing positional argument, college. Sorry, what? This is college, this is college. Name and college we have inherited from here, yes. Where is the problem? Missing one positional arguments. Okay, maybe we have to pass self here. Let's see. Okay, so now it's working fine. See here, I am Prabha, studied in JNDH, joined as data engineer in ABC with a salary of 50,000. It's working fine. Employee info is working fine. Now let's say uh, I'll apply student info now on the employee method. The student info. Let's run it. See here, student ID is, sorry, student ID is something at, and student name is Prabha. So ID is not properly considered because we did not inherit or we did not pass the value here. Let's say we'll also use ID, student ID. So here let's take the ID. So the student ID, employee ID is 100, student ID is 1. Okay, let's run this now. But 5 were given where ID, name and college are taken from here. One second. What are we missing? Organization, designation, organization salary. Okay, it is good. Now at what line it is throwing error? Here. Student init takes 4, but 5 were given. 1, 2, 3, 4, 6, 7. 1, 2, 3, 4, 6, 7. It's correct. What's wrong here? Let's see clearly. Let's remove this word self and see. Okay, now it's working fine. Previously also we did not use self. Okay, right. Okay, self is not required. So now we are able to call the student information as well. Now let's try to bring person info. Is that accessible or not? Because person is not the direct parent for this employee. It's the parent for student. Let's see. Yeah, now it is working. So now all the methods. So now initially the granularity is like person is the base object. On top of the person became the student. Now the student became the employee. Okay, even though uh, only the student is the parent of this employee, whatever are the attributes of parent, sorry, person, that is already acquired by student. So now all the properties will be given to the grandchild. It is like you have your grandfather, your grandparents, your parents, and you. Whatever properties inherited by your parents from their parents, so all of that will accumulate to you. You will get both their properties. Okay, this is called hierarchical inheritance. Hierarchical inheritance. And this is called single inheritance. Single inheritance. Okay. So we also have something called multiple inheritance. Multiple inheritance. Let's see what it means. I'll take the same example. Okay, I'll change little bit here. Sorry, child having multiple parents. Okay, so let's define another independent class, or let's remove this and make this student as an independent class. So define self dot name equal to name. Now these two are two independent classes. Person and the student are independent classes. Okay, now employee, it will accept student and also the person. Okay, so or else let's say instead of person, I will make a parent. Okay, parenting. Okay, let's say these are the details of his parents. Okay, now employee is inheriting both two parents. Employee is having two parents now. Let's run this first. I'll show you the other details later. Also call this method. Now what are all the properties this employee will get? So this is student and a parent. These are the independent methods. Now this employee has two parents, student and person. Let's see. Here what are all we have to inherit. Okay, this is fine. I think it might be confusing. This is parent name. This is student name. So let's also inherit. This is employee name. Let's say the student has become the employee now. So this is fine. Let me also inherit the parent name. Okay. So, so now as we have multiple parents, inheriting directly using the super method is not possible. Let's see. I'll run it. Name is not defined. Where it is not defined, this is student name. Sorry, here we have to use S name. So let's say this is S name. Name is not defined. Where? Okay, self dot name here, and here as well P name. Let's change it everywhere wherever we are referencing them. Okay. Okay, now employee information is working fine. Let's call Student info. It's giving error. Employee object has no attribute as name. Student ID is self.id and student name is, where am I missing is name. Student ID is the student name is self.s name. Am I missing? Employee object has no attribute as name. Okay, employee ID, name, S name is there. College, designation, organization, salary. Okay, so fine. So let's say we also want P name. Okay, now I'm something and parent name is self dot p name. Let's modify it a little bit. Self dot p name, study name, so and so college. Now we have two parents. Okay, we have two parents, and how do we use them? Use the variables from both the parents. If you run it this way, it will be definitely a problem. So let's ignore about the student info. We will discuss about the student info later. So at least this part, okay, it is giving error. P name is not defined because by default uh, it will understand that the variables are all from the first parent. Okay, so in order to make it understand it as a two different parents, how do we get it? So let's see. Let's use the class name here, student of these details, and what is the other one? Parent of, sorry, parent dot, sorry, parent dot init of p name. Let's try it this way. Still there is an error. Student requires 3. Yes, student has 3 and this parent has 1. What's wrong now? I did not even call the student info. Okay, let's see if the variables are correct or not. Second. It might be little tricky and confusing. It all comes with the practice. So did we pass? Okay, p name we did not have it in the variables here. That's why it's taking it as an error. Okay, so let's see. Still, okay, one more name is required. Employee ID, student ID. This is student name. Let's say the parent name is, let's take any name from the participants. Okay, this is the parent name. Okay, right, let's run it now. Missing one, miss student in it, missing 3 positional arguments. Okay, let's do one thing. Mm, this way of inheriting, this is correct. So there is nothing wrong here, but while calling, it is not accepting, right? Let's say, let's use the self. Okay, still not working. Hmm, what we can do? I have passed all the correct values. Employee ID, student ID, name, another name, college, designation, organization, and salary. Student, the spelling is also correct, and the parent is also correct. Its P name. Okay, these brackets are not required. Once again, employee has object has no attribute P name. It has. Let's try without this self. One second, I'll explain you what I'm trying to do. Now it is missing college. Employee object has no attribute P name. P name is there. What? I am self dot name. Do we have name here? Okay, that's the problem. Name is not there. Self dot s name, and the parent name is self dot p name, studied in self dot college. Okay, good. Let's see now. Employee object has no attribute s name. This is so weird. Let's make it employee one. Maybe it's referencing from the previous values. I got it. So here it should be S name and it should be P name. I did not change it on the left side. Okay, now it's working fine. So now let's see carefully. So we have two different parents now. Parent is the one parent and the student is another parent. These two are two independent classes. Okay, so we have some methods, parent info and student info. I have defined a employee class with student and person. Sorry, this is the problem. Student and parent. Okay, so this person is also accepted because somewhere previously we have the person class. That's why it was accepting. Okay, so while inheriting the properties of the two parents, instead of writing a super method, we should write that particular class name with the init method and the self. Okay, so whatever you want to get it from the parents, you can get it using these methods, and remaining things you can get it using the self. But while accessing, you can access it by using the self dot. So now the employee info is there. Now let's work on student info. Okay, student ID is one, student name is this. Yes, it's working fine. Now let's say the parent method, parent info. Is it parent info or person info? Yes, parent info. Let's run it. Okay, the person name. Instead of person name, let's make it the parent name. Okay, the parent name is Bhargavi. Yes, you are able to access all the attributes. Let's say I have some method which is common or between employee and a student. Let us say here I will have def of student info. Okay, student info is already there in the student class. I am defining it here again. So here let's say print instead of student, uh, I'll write I. I am self dot s name. Here we are talking about the student name, so that's why I'm taking s name. I am studied in self dot college. Okay, so here if you look at the information here, student ID is the third person is introducing the student. Student ID is this, and student name is this, and studied in so and so college. Now the student is introducing himself in the employee class. Now let's run this again and see what happens. Error, but one was given. Student info. Sorry, self is not missing here. Okay, so now let's see. I am Prabha studied in JNQH. Okay, so this student info now is taken from the um, child class, employee class, though we have the same method there in the student as well. Okay, so the preference is if the same variable or method is already available in the child, then the child will be given preference. If not, it will look in the parents. Which parents? First, it will look in the first parent. If it is not there in the first parent, then it will search in the second parent. Okay, so now let's define another method here. I'll write it here. Child method will be given preference. If we have the same method names, the child method will be given the preference. Let's say we will have another method. Hmm, what I can do? Okay. Let's say now the parent information is available only in the parent class. Let's say I'll also make it available in the student class. Okay, I'll also make the parent information available in the student class. Okay. Instead of the parent name, my parent name is okay, P name. So here we have to inherit that using the super method. It might cause problem again. Let's see. Init of P name. Let's also write P name here. Okay. So let's run it. Okay, error. Where is it? Okay, here. It is incomplete. Let's run it. Again an error. Student init missing one positional argument. P name. Maybe super doesn't require the word self. Let's do. Uh, let's use parent. For parent, we have to use self comma. This will let's run execute it. Missing student init missing one positional argument p name. Why we have already defined it. One second, let's see what it is what is happening here. Student init method. Sorry, init missing one positional argument p name. Did I not use those words correctly? P name. This is fine. Okay, let's not use this parent here. It might be double calling. Still the same. Let's use super. Missing student init, missing one positional argument p name. Because this is not the parent here. That's why we are using incorrect method. Okay, so that's not the parent. These two are two independent. That's not the parent. Let's say uh, the parent name is, let's also have self dot p name. It might confuse you. Let's say marks self dot marks equal to mark. Okay, so now instead of parent info, let's take this. I want to have some common method between these two. Let's do one thing. I'll write a dummy method. Def of m1 of self. Okay, so let's print a student m1 method. Okay, so I will have the same dummy method in the parent class as well. So m1 of this time parent m1 method. So the method names are same, but the content inside that what it is going to return that is different. So let's see. Now I'll apply that e dot m1 method. Okay, e dot m1. Still, what is the error? Marks, where is it? Okay, now it's working fine. See here, now M1 method is available both in student and person. But from where it has taken? Student M1 method, because student is the first parent. Okay, student is the first parent, that's why it has taken from the M1 method. So the order of checking is, first it will check if M1 is available in the child class. If not, then it will check in the first parent. If not, then it will go to the second parent. That's how the order of execution follows. If the M1 is available here itself, then it will take from the child class itself. Okay. So while inheriting, first parent will be given the first preference. Okay. While inheriting, the first parent should be given the first preference. Or if it is there in the child will be given first preference, next the immediate parent, and next the next parent. Okay, let's say M2. Therefore, M2 of self print parent M2 method. Okay, now this M2 is not there in the other classes. That's why it will take from the first parent. Okay, parent M2 method. Hope you are able to understand. So if you have multiple, the things to take away is, if you have multiple parents, just use the parent name reference. If you have only a single parent, use super reference. Okay, if you have single parent, use the super reference. While using the super method, you no need to pass self. But while using the parent reference, parent name reference, you have to use the keyword self. Okay, so those are the key things to understand. Okay, that's all about inheritance. Now let's switch to polymorphism. Polymorphism means the same thing behaving differently. Okay, the same method or same class behaving differently. So let's see. Uh, let's discuss some simple thing. We have a plus operator in Python. Okay, plus right? So print, let's say 10 plus 20. What does it do? It will do mathematical operation 30. So let's say I'll print string A plus string B. What it does, it is doing string concatenation. So based on the given input, the same plus operator is behaving differently in many forms. Poly means many, morphism means many forms. So many forms. And the same method or the same operator can behave differently. Okay. So here in polymorphism, we have different two different things called method overriding and method overloading. Overloading. Let's see with the examples. I'll show you some simple examples. Anyways, we are not going to use this much in our uh, data engineering projects. Okay, so let's first is method overriding. So let's create a class called parent. So here the method called show method of self. I'll write some simple functions without variables and all because you already understand how to use the variables from parent to the child. So this is, here I'm not using any constructor. The constructor means the init method. So this is parent. Okay. Let's create another class child with parent. Okay. Here also I'll define a show method, show of self. There is nothing new here. These methods we have already discussed. This is child method. The name is same. In both the classes, the name is same. The show method. So when you are having the same methods in different classes, it is getting overwritten. Let's create a child object and call the show method. Now what will be displayed? Whatever method is there in the child class, that will be printed because show method is available both in parent and child. Okay, this is child class method because the method is available in the child, so the child will be given the first preference and the parent will be given the next preference. Okay, so this is called method overriding. The same method we are overwriting it. Okay, the same method we are overwriting it. Uh, okay, and let's see method overloading. Method overloading. So let's say we have a class which adds numbers. Okay, so inside this I'll have some method def of sum of self comma a b c equal to 0. Okay, return a plus b plus c. Now let's say a equal to add and print, sorry, not print, a dot sum, a dot sum of 10 comma 20. Okay, it is taking 30. Now let's say a dot sum of 10, 20 and 30. So C has a default value, but we are overwriting that. Now it is giving 60. Okay. So Python doesn't really support true overloading. Okay, let's write here Python doesn't uh, truly support overloading. Okay, but the same operator behaves differently as what we have discussed, but same operator, for example, plus behaves differently. Okay. On the numbers, it will do mathematical operation, but on the strings, it will do concatenation. Okay. So let's take another example. So, okay, let's take another example. Let's say class of animal. It makes some sound, f of sound. So this makes some sound. Let's say print some sound. Now I'll have another classes. Class of dog. Let's say I'll not pass any parents. f of sound of self. Print bark. Okay, the dog barks. The sound the dog makes is it barks. Let's say another animal, cat. Okay, it makes some sound called meow. Okay, let's say we have these animals. Let's create a object references. D equal to dog of D equal to dog. T dot sound. What it does? Okay, dog barks. Similarly on the cat method C dot sound. Okay, so it is making some sounds based on the classes. So the same classes we have different methods. Sorry, the same different classes we have the same method, but the functionality is different. It barks, it makes the sound meow. So maybe some another animal makes some other sound. Let's say I'll take this into list animals equal to or a equal to. I'll take list of dog, comma, cat. These two are the classes we have. For x in a, let's make those sounds. X dot sound. Okay, depending on the animal we are passing, it makes the corresponding sound, right? Yes, it makes the corresponding sound. So the same method using the same different classes using the same method, they are making it behave differently. So this is called polymorphism. The basic concepts are method overriding and method overloading. Okay, overriding means the same method behaving differently. When we have a parent and child classes, when we have the same methods in both of them, it is getting overwritten. Okay, this show method is overwritten by the child class show method. That's why this is given the first preference. In case of overloading, they behave differently. It's not truly overloading, but still the operators plus behaves differently when we are operating on the strings. The same applies for the multiplication as well. The star symbol. When we are applying on the numbers, it does mathematical operation, but when we do it on the strings, it does a string replication. Okay, that's about polymorphism. Okay, let's see abstraction now. Abstraction is like, so in the college days, you might have presented some seminars during any of the technical events. Okay, so at that time, when you are registering for that seminar, you don't know much details about that. Maybe you know on what topic you are going to present, but how many slides, how much time you are going to present. So what particular details you are going to present, that you don't know. Okay, that you don't know. So but somehow you are registering for the session by giving some basic details. That's called abstraction. You are giving only the basic details. On the day of presentation, you will uh, present all the details. Okay, you will complete that later. The full details you will complete it later. That's called abstraction. Okay, let's see abstraction. So we don't know the real implementation. So how many numbers or how many variables, how many methods, all of that I don't know right away. Okay, I don't know right away. I'll create some template and I'll fill that later. Okay, we don't know the real implementation. Just have an idea of requirement. So for that, we will write an abstract class. We'll write an abstract class and complete it later. Okay, we'll write an abstract class and complete it later. So let's see with an example. So for using the abstract classes, we have to import something. Okay, from ABC. ABC represents abstract base class. Import ABC comma abstract method. So these are the methods we have to use for declaring the abstract classes. Let's say the class of vehicle. I know there would be something called vehicle. Okay, this vehicle I don't know the functionality. How many variables, how many methods, I don't know nothing about it. So I'll make it as abstract base class. Okay, so I'll define an abstract method here. Let's define a class of start of self. So I don't know what to do here as well. Let's say pass. If you don't know anything and if you want to just pass the syntax, you have to use the word loop. Sorry, pass. So I think I did not tell you. Let's say if a greater than 10. I don't know what to do, but I don't want to make the syntax fail. For that, you can use the word pass. Sorry. A, let's say a equal to 5. Okay. I don't know anything about here what to do. I'll write pass. Otherwise, it will say incorrect error. Sorry, syntax error. Okay, that's why I am writing here the word pass. Let's say now what vehicle I don't know. Is it a bus, car, or lorry, or whatever it is? I don't know. Right now I don't know. I'll complete it later. So let's say now I'll know what vehicle is. Let's say I have a car. Okay, car. It should accept this as a parent. Okay, car of vehicle. So let's say instead of start, I'll say number of wheels. Okay. Depending on the vehicle, the number of wheels change, right? For car, it might be 4. For bus, it might be 8. Or lorry, it might be more. Okay, depending on the type of vehicle, the number of wheels change. Now let's say def of number of wheels of self print car has 4 wheels. Now you know what functionality you want. So you have created that class and completed the method inside that. Okay, let's create a object reference c equal to car and c dot number of wheels. Okay, vehicle, let's see. Okay, I did not execute that. Okay, now car has 4 wheels. We did not know the functionality here, but we just know this is something about the vehicle and some number of wheels based on that. So I'll complete it later. This is called abstraction. Okay. Now encapsulation. I'm just going through on a high level because these are not really important for the data engineering aspect. Okay, now let's say encapsulation. So encapsulation is nothing but binding together all the methods, variables as a single unit. That's called encapsulation. binding together of all variables, methods as a unit. So this is called encapsulation. Okay. So when it comes to encapsulation, we have three different types of variables. Types of variables. There are three types: public, protected, and private. Okay. So public variables are like whatever variables we have discussed so far, those are all public variables. Let's quickly create a method class person. Here I'll have some method init of self, comma, name. Self dot, or let's say I don't pass name here. Instead, I'll pass hard-coded value. Self dot name equal to my name. Okay, let's create a person object reference and let's print this name p dot name. Okay, it's done. So this is a public variable. So just like whatever we have used so far, it's good. Now let's say I'll use protected variable. So self dot, let's say I want my age to be confidential. Age. So when we say protected, which means it is having restricted access. Let's say in the organization, there will be some documents which are accessible only by the members of the organization. So members outside the organization, they'll not be able to access. Okay, that is called protected. Let's say my age. Let's say I want it to be confidential, or I want only certain persons to know my age. Let's say print self dot age. Underscore represents protected variable. Okay, names, sorry, not self, it is p dot. Okay, but still we are able to access. So which means members of the organization, they are able to access. Let's say I have a salary. Salary is my private variable. I don't want anybody to let that know. Okay, let's say 50,000. Now try to access that outside the class p dot underscore underscore salary. See here, person object has no attribute salary because this is a private variable. Private variables are not accessed outside the class. Sorry, this is protected. And this is private, not accessible outside the class. Okay, private variables are not accessed outside the class. Strictly speaking, I mean, there is a way to access the private variables outside the class as well, but Python strictly doesn't allow private variables. But still, there are some methods which we use to access variables, private variables outside the class. Okay, so let's see how do we get that. If you want to display the salary, let's say we have to write a method def of salary of self print self dot name is getting self dot salary. So let's apply this method p dot salary. Let's comment this. Okay, we are getting that. So strictly speaking, we will still be able to access the private variable outside the class. Let me show you. So p dot underscore And so the class name is person underscore underscore the variable name salary. So this will allow us to print the private variable outside the class. Okay, this will allow us to print the private variable outside the class. So that's why it is strictly not private. Okay, so possible to access private variable outside the class. Okay, so just for the namesake, we will say we have three types of variables, but still Python is not very secure to hold these kind of details. Okay, not very strict security. Okay, that's all about encapsulation. It's the process of binding together all the data and the methods together. Okay, so I'll stop it here. So with this hoops concept is completed, tomorrow we'll start with the API and then we will start SQL as well if we are able to complete API. Okay, so I'll share this file in the chat window. Please let me know if you have any doubts.